See, here we are trying to find out the unit elements in these rings. So what we mean by unit element? There are two words. One word says unit, and before saying unit, there is another word unity. Unit comes later. Basically, I need a unity. Then I can think of unit element. So what do we mean by unit element and unity? Let us see the difference. See, you are in a ring. There are two operations defined, addition and multiplication. You know better, for addition, R is a group, more or addition is commutative, so it's abelian group that we all know. Means it has to have additive identity, additive inverse, etc. But that is not the case with multiplication. With respect to multiplication, R must be binary, I mean closed for multiplication, associativity of multiplication, and multiplication should distribute from left as well as from right over addition. So these are the requirements for a ring. Now, if you have any element like A multiplied by some element, you get back A. Then that element 1 we call as unity. If your element remains the same, and this is true for every A in R, that element 1, the fixed element 1, we call as unity. But if for A you have another element B such that A into B is the unity element, A into B is unity, then that specific B we call as unit element for A. I mean inverse of A. And because A is invertible, A is known as unit element. If multiplication is not commutative, then you will have a left inverse as well as right inverse. In the present case, B is on the right side, so it is known as the right inverse of A. And if B is written on the left side, then we call it as left inverse of A. So there are two terms, left inverse and right inverse. If at all A is having inverse element, then A is known as unit element. So there is a difference between two words, unity and unit. Is this fine?
Oh, madam.
Okay. Now we would like to move to how to talk about the, yeah, talking of this particular. You have four sets given, Z, sorry, three sets are given, Z, Z5 and Z4. What is our Z? Set Z is our usual set of integers. What are the elements in Z? As you know, it is unending to both the sides. So let us say dot dot dot, comma -2, comma -1, comma 0, comma 1, comma 2, and so on. So this is an infinite set, you know, infinite to both the sides. And what will be the unit, what will be the unity in this particular? Unity in Z. So what is that element by which if I multiply to any integer, the integer will remain the same. So what is unity in this case? Unity is 1. 1 is only
One.
element. 1 is the only element by which if I multiply, every element remains the same. Like A into 1 is A for any integer A. So 1 is the unity element. Now what about unit element? Unit element means the element should be invertible. If I multiply 1 by 1, I get answer 1. If I multiply -1 by -1, I'm getting back 1. Now, if I multiply to 2 by something so as to get 1, what is that element I should write over here? It should be half. Then only with usual multiplication this is possible. But half is not an integer. Half is not present in my set. This is not possible. And that's why we say 2 is not invertible. 1 is invertible, minus 1 is invertible, but 2 is not invertible. So what are the unit elements in Z? Unit elements in Z are only 1 and minus 1. As you saw in case of 2, same thing you can observe for minus 2 also. Same thing you'll observe for 3, minus 3 and so on. So only 1 and minus 1. These are the elements which have inverse. So they are invertible, means they are unit elements. Followed me now?
Yes.
Okay. Now let us move to the next element, that is Z5. And so many times we have observed that the elements in Z5, if I talk about non-zero elements, they are all invertible. 1, 2, 3 and 4. What you need to do is you prepare multiplication table for this. And once you prepare multiplication table for Z5, you'll come to know that every element has got inverse in it. So you can check for it. You can have elements over here 0, 1, 2, 3 and 4. Never forget we are in Z5, means whatever operation we perform, the answer is divided by 5 and remainder is taken as the answer. So you can see if I multiply by 0, every number goes to 0. So talking of unit element, we never think of 0. 0 is no time unit. 0 is not there. Then you can go for 1. You multiply every element by 1. What do you get? The element remains the same. Meaning 1 is the unity. It keeps the element as it is, whether multiplied on left or multiplied on right. So 1 is the unity element with you. Now what you require? Now you require the answer to be 1. Now let us go for 2 2s are, it's 4. 2 3s are 6 divided by 5 because we are in Z5. Remainder is 1. And 2 4s are 8 divided by 5. Remainder is 3. Same way you go for 3 2s are 6. Remainder is 1. 3 3s are 9. Remainder is 4. 3 4s are 12. Remainder is 2. Next you go for 4. 4 2s are 8. So remainder is 3. 4 3s are 12. Remainder is 2. 4 4s are 16. Remainder is 1. So what you are observing here, here you get remainder 1. Here the answer is 1. And here also you find the answer is 1. In the row of 1, you'll find 1 over here. What this means? Inverse of 1 is 1. Inverse of 2 is 3 here. Inverse of 3 is 2. And inverse of 4 is 4 itself. Are you following? So what are the unit elements in Z5? 1, 2, 3 and 4. We always think of non-zero elements. Is there any doubt?
मॅडम तिथं Z5 दिलेला असेल आणि युनिट एलिमेंट काढायचं असेल तर मल्टिप्लिकेशन टेबल क्रिएट करायचं का?
If Z is given, Z contains infinitely many. If you are talking about set of integers, there are infinitely many elements, so you cannot prepare a table. But when it comes to Z5, when it comes to Z5, you can have this kind of table. This Z5 contains finitely many elements, so it is possible to have table like this. Okay?
मग मॅडम युनिटीसाठी मल्टिप्लिकेशन टेबल काढायचा का?
Not for unity. Unity You can observe what is the element which when multiplied to the remaining elements, the elements remain the same. That we can easily see. But to find the
Hmm.
unit element, we need to prepare this kind of table. Such a table helps you to explain the things. Okay?
ओके मॅडम म्हणजे का आपण ऍडिशनचा पण तयार करतो ना आपला टेबल.
Yes, but because you are talking about unit and unity, these terms are referred with respect to multiplication. They are not for addition. For addition, we say additive, identity, additive, inverse. Talking of multiplication, the identity is known as unity, and invertible element is known as unit element. Is it fine?
ओके
Okay,
यस.
okay. Now, if
Ma'am,
we
directly
put,
also
I didn't get you.
ma'am, directly also we can predict na ki 2 into 3 that the remainder will come out to be 1
Yeah.
because and 3 so 2
Yeah.
and 3 are invertible to each other. So sorry, they are unit elements of each other.
Let us go to that point. Already we have discussed so many times, and that's why we have another I mean say it over here in the question paper. You had Z4. So let us talk about what happens to Z4. What is Z4? Z4 contains 0, 1, 2, and 3. Now there are only 4 elements with us. We can prepare multiplication table. Let's have multiplication table over here. This is for multiplication. Modulo 4. I have 0, 1, 2, and 3. Here also I have 0, 1, 2, and 3. Okay. If I multiply by 0, all the elements vanish. And that is why we never take 0 into consideration. Vertically also you'll have zeros. Okay. Now let us come back with 1. If I multiply by 1, the elements remain the same, and that is why 1 is called unity. Whether you are multiplying on the left or on the right, the element remain the same. Now you can go for 2 to the 4. 4 divided by 4. What is the remainder?
0.
Yes,
Zero.
remainder is 0. That is why answer is 0 here. Now 2 3s are 6. What is the remainder?
So,
Yes, it is 2. So this is the product that you watch here. Now talking of 3. 3 2s are 6. Remainder is 2. 3 3s are 9. Remainder is 1. So what you observe? Answer 1 belongs to this row and this one. I hope you followed. In the row of 1, I find answer to be 1. So I can say 1 is invertible. And in the row of 3, I observe 3 3's is 1. Means what? 3 has inverse as 3. Inverse of 3 is 3 itself. 3 3's comes out to be 1. So it is an invertible element. So what are the invertible elements in Z4? 1 and 3 only. And just now you were talking about the prediction. Here it comes. What we do? We go to Zn. In Zn,
ma'am, prime is
yes,
if n is prime, then also we can they are
yes,
unit
yes,
na.
yes, I'm coming to that. You're right. If we talk about Zn, then every element starting from 1 up to n minus 1 we have in this particular set. That is the thing. We come from 1, 2, and so on up to n minus 1, as you all know. Okay, this is nothing but your Zn. And there is one more entry, that of 0. Okay. Now, you know very well that every of these elements is relatively prime to n. GCD of n with 1 will be 1. GCD of n with 2 will also be 1 if my n is prime. So prime integer is always relatively prime to every other element belonging to Zn. And in that case, the element becomes invertible. We never think of inverse of 0. So 0 is discarded from this. So about non-zero elements we are talking. So all elements in Zn except 0 are unit elements provided n is prime. And in case of Z4 you are watching, 4 is not prime. So only 1 and 3 are invertible. 2 is not there. And we never think of 0. So 1 and 3 are the only units in Z4. Followed me? Suppose you are getting. Okay. Now, I think the first question is quite clear to you now. Talking about all units in the ring. Is it fine now?
Oh, madam.
Okay. Then we were to talk about what happens in case of Cartesian products. If you are having Z cross Z, what do you mean by first of all Z cross Z? This is the set of pairs, and the pairs are called ordered pairs because ordered pair AB is different than ordered pair BA, as you know. From where to take A? A is taken from the first set Z, B is taken from the second set Z. So actually both places contain the same set. So you might have said A comma B belong to Z, that will work. Okay, we are talking about ordered pairs. Now the question is, what are the unit elements in this Z cross Z? So how the things run in the Cartesian product? So whenever you are having two elements like AB as first ordered pair and ordered pair CD is your second pair. And now you want to multiply them. So what will be the product? So you multiply A into C component wise and B into D. So component wise multiplication takes place in case of Cartesian products. So Suvarna, you were confused in this particular. Okay.
Yes, ma'am.
Yeah, and that's why I repeated this. Z cross Z always talks about ordered pairs. First element is carried from the first set, second element is carried from the second set. You cannot shuffle them, you cannot interchange their order, nothing. But whenever you add, place-wise addition takes place. Whenever you multiply, place-wise multiplication takes place. So this is what happens in case of Z cross Z. Now what will be the identity element? Identity meaning unity. Unity in Z cross Z. So if suppose you are having ordered pair AB, by what element you will multiply it so that you will get back your AB? Can you guess? I want the first place to be A. So by what I should multiply to A so as to get A?
1,
Yes, it must be 1. And
1, 1,
second place? Yes, 1, 1.
1.
So what is the unity here? 1, 1. 1, 1 is the unity. Now one more thing. Which elements are unit elements? Which elements are unit elements? Meaning answer should be 1, 1. Answer should be the identity, meaning unity.
1,
So,
1, minus 1, minus 1.
yes, so if at all I'm having AB multiplied by something and getting answer as 1, 1, what should I have in this
A
place?
plus B
1 by
inverse
A, and here it should be 1 by B, or
1
you
by
may
B.
call it as A inverse and B inverse. Okay, so this is quite better. You call it as A inverse comma B inverse. Now go back to your first set Z. If you go back to your first set Z and find what you happen, what happens? Multiply A into 1 by A, you get back 1. But 1 by A exists only in case of 1. So if you are handling 1 in the first place, here also you should have 1 in the first place. If you are having 1 in the second place, it should be 1 in the second place. Then and then only you will get ordered per 1 1 as the answer. Now you go for 1 comma minus 1. What will be the inverse? Place wise multiplication it is. You want the answer to be 1 1, you know. So 1 multiplied by what produces 1?
1
Yes, so this place fixed as 1.
minus 1.
Multiplied to what gives me 1?
Minus 1.
Minus 1. Inverse of 1 minus 1 will be 1 minus 1 only. Followed me?
Yes.
Okay. Now going back to minus 1 comma 1. What is the inverse? Yes, anyone? Inverse of ordered per minus 1 comma 1 will be back minus 1 comma 1 only. If you go like minus 1 comma 1, what is the product? Come on,
1 1.
1 1.
Plus 1 1.
Yes. And if I take minus 1 comma minus 1, then what is happening? What is the inverse of this?
Minus 1 minus 1.
Yes. Minus 1 comma minus 1. Answer is going to be 1 comma 1.
1.
So what are the unit elements here? Only 1 1, 1 minus 1, minus 1 1, and minus 1 minus 1. Only 4 elements are invertible, and so you call them as unit elements. Followed? Okay. All right. Now if I go to set of rationals, then what is going to happen? If I go to set of rationals, how is the set of rationals? It is the set of the pattern P upon Q. What are P and Q? Yes,
Integers.
yes,
To Z.
P and Q are
Integers.
integers, and Q should not be,
Not equal.
0.
yes, Q must be non-zero. Okay, so this is the set of rationals. Now the question is, in case of rational, what are unit elements? To think of unit elements, I have to think first of what will be the unity? Unity in Q. What is that element? If I multiply by that element, my P by Q will remain as it is.
1 by
Yes,
Q by
1.
it will be 1 only.
1.
Either you call it as 1 upon 1 or call it as 1. Followed it? So 1 is the unity. 1 is the unity. 1 is the unity in Q. Now what are unit elements in Q then? Unit elements means invertible elements. Which elements are invertible? If I take any general P by Q, by what should I multiply it so as to get 1?
by P.
Q.
It should be Q by P, no doubt. But if P is 0, then what will happen? If P is 0, because Q non-zero is the condition. But if P happens to be 0, then what you will do?
P non-zero.
Yes, the condition is P must be non-zero. And P is non-zero element will mean that this P by Q has inverse Q by P. So every non-zero rational number has inverse. So every non-zero rational will be a unit element. Followed it? every non-zero rational is a unit element. Okay. Okay. What comes next is, if suppose I have ordered, Z cross Q kind of set, Z cross Q kind of set. So what will be the unity and what is the unit element? What will be the unity and what is the unit element? You know very well. Your
Plus minus 1 P by Q.
once if I write plus minus 1 comma
P
P
by
by Q. So are they invertible? Are they invertible? How many pairs are there in all? Only two?
प्लस 1 आणि मायनस 1 Z मधले आणि Q मधला P by Q.
So with one, you'll have P by Q kind of,
-1 ने नाही येणार ना मॅडम.
and with minus one, P by Q kind of terms.
P by Q.
So how many are there? How many are there? Infinitely many. How many rational numbers are there? They are countable, but infinite. You know this. So this set is denumerable, but infinite. Is it right? So there are two kinds of pairs. One is 1 comma P by Q. Other is minus 1 comma P by Q, provided P is non-zero and Q is non-zero. Fine. Getting the point? Pradnya, you want to ask something? No, I couldn't hear you.
मॅडम किती ऑर्डर पेअर येतील?
Infinitely many.
ओके.
So I think you are capable of solving this kind of things. In the journal, you have such kind of questions. I'm sorry. If suppose you have Z cross Q cross Z, then what are the possibilities? What is unity and what is unit element? First of all, I want unity, and next I want unit. Huh? What is unity?
प्लस मायनस 1 P by Q आणि प्लस मायनस 1.
No, I'm talking about unity. Unity is the
Unity.
element which keeps every element as it is. So naturally it must
One,
be 1
P by
comma
Q.
1 comma 1. What is the unity? 1 comma 1 comma 1. So you can check if I multiply by 1 1 1 to every element like a comma, suppose I have P by Q comma B, then what is the answer?
Same.
Now first place multiplied to first place, 1 into A. Second place to second place. So second place will be P by Q. And third place, right? So I suppose you are getting triplet into triplet. You got back the original triplet. So 1, 1, 1 plays the role of unity. Then what are the unit elements in this kind of set? So for Z, you know the only unit elements are plus minus 1. For Z again here also you'll have plus or minus 1. And for Q you have every P by Q, only P is not a 0. So what is the requirement for you? P not 0. So how many triplets you got? How many triplets you can form out of plus minus 1, plus minus 1?
Countably infinite.
Yeah, of course. But with the help of plus minus 1, you can have ordered pairs 4 in number. And those 4 along with all P by Qs, you can have unit elements. Followed me? So I think we underline the concept of unity and unit element. So you can check. The question was like describe all units in the following ring. So we just talked about unit elements. Sure. Now the next question says, yeah, the question is not completely displayed over here, but you were required to find out the addition table and multiplication table. So I think the second question was quite easy. Third question also was quite easy. You have just to go with the polynomial rings. Today we wanted to discuss on polynomial rings, but I thought this was actually the recent thing. So we went back over there. What do you mean by Z2 of X? What is the meaning of Z2 of X? Can you tell me? So know better that this kind of notation is for the set of all polynomials whose coefficients lie in Z2. Is it right? All kinds of polynomials whose coefficients are taken from Z2. So Z2 of X is the set containing all polynomials with coefficient either 0 or 1. So last time we have simplified this. And you know very well, whenever R is a ring, then R of X is always a ring. If R is a ring and you just take the coefficients from R and form polynomials, then this particular set forms a ring under usual polynomial addition and polynomial multiplication. And what do you observe, this R is a subset of R of X. Do you agree? R is a subset of R of X. Now in such situations, R of X becomes a ring. R of X becomes a ring. Let us check this statement over here. You can check here as a theorem. The set R of X of all polynomials in an indeterminate X with coefficients in a ring R is a ring under polynomial addition and multiplication. What it means? If R is a ring, R of X also is a ring. Further, if R is commutative, then R of X is also commutative. And next, if R has a unity 1, then R of X also has unity 1. 1 not equal to 0. If the unity is 0, then it becomes a 0 ring and nothing is left in your hand over there. Followed me? So for today, I would like to stop here. I request you to revise the topics. Is this fine?
Thank you, ma'am.
Okay. Bye then.